Welcome, ladies and gentlemen. We have this, we are still continuing my coordinate geometry, so of which we are on question number 4. So not forgetting what question number 4 is about. It's under coordinate geometry. So this is question number 4. So the question is about, let me say, to say the point A, B, and C. They have coordinates -4, 2, 7, 4, and -3, 2, -3, 1. Hence, the first question is to say, draw the triangle ABC. Second, I sent to say, show by calculating the triangle ABC is isosceles and name the equal sides. So I have to prove that this angle or this question, it's all about showing or proving two sides to say, or let me say the triangle that is isosceles, and also showing the angle which are true, contributing to be isosceles. The question 3 is to say, find the midpoint of the third side. So which means those sides which is not equal. We have to find the midpoint of itself, not forgetting the formulas. Then last one, calculating, or let me say by calculating the appropriate length, calculate the area of the triangle ABC. So what's going to happen here? We have coordinates such as A, 4, 2, B, 7, 4, C, 3, -1. Therefore, we need to draw the triangle as a first question. What's going to happen first of all, before we're going to fill, first of all, you just have to come up with a scale. What is that scale? By the way, you have to label it as you're coming up with a scale to say this is X, this is Y, this is X, this is Y, this is also X, this is Y. You know what's going to happen once you come up with such kind of labeling? We want to say this is X in terms of negative, it's lying in the X-axis. This is also X, it's lying in the X-axis. So what's going to happen? Come up with a scale. We're going to say both in a negative or negative and positive, lying in the X-axis. We have to say the X represent to say 2 centimeters. Since we're not using the graph here, 2 centimeters representing 1 unit. But long in the left way, 1 unit. That is X-axis, because both negative and positive. If you try to see the negative, or let me say the X-axis, the X-axis when it comes to the X values, they're starting from, let me say the highest one is -4. That's the smallest one. Then here we do not have the highest one, the smallest one. So if you see very much for what about the negative, it is 7. So if you maintain 1 unit, it's quite interesting. What about X, in the Y-axis? So it's a Y, which one the highest now? I've got 2 here, 4, which means 4 is the highest. So if we try also to maintain the same, to say 2 centimeters representing 1 unit, it's one and the same, and also it's trying to play through both X-axis, both negative and positive. Can we draw it roughly here? Okay, so this is at the center, and this is our Y-axis. Label it very much clearly. X-axis. Okay. So what's going to happen? Let's start with negative. We want to say negative align from 1 up to 4. -1, -2, -3, -4. That's the X-axis. We want to say we're covering also this one. What about say as Y-axis in positives? The highest one is is 4. So we maintain the same unit as 1 according to the scale. 1, 2, 3, 4. We know these are positives. What about the negatives? The negatives, we only have 1, which is as negative 1. Now, can we go back in positive x-axis? We want to say I've already written or indicated the x-axis, which is in form of the negative. What about x-axis, which is in form of positive? We want to say the highest one, the 7. If we maintain the same units, we're going to say this is our 1, 2, positives, 3, 4, 5, 6, up to 7. Note, we're trying to use this one as the last one indicating, but if you have a graph, it's going to come out clearly and perfect. Okay. Coordinates of A, it is negative 4, 2. So if we say in x-axis, negative 4, 2, 4 negative, as in 2 positive. So the point is lying here. And you get it clear to say, this is the coordinates of 4 and 2, negative and positive. Now, we're done with A. What about B? X-axis 7. So that means we're going to have 7 to 4. So 4 is going to be somewhere here. And indicate it clearly to say this is 7, 4. As in this is X, as in this is Y. Also this is X, this is Y. So what's going to happen once you do that, we go to C. What is C? C starts with negative 3 in x-axis, comma negative 1 in y-axis. So this is down one. And is lying here. It is lying there. So it says this is C, negative 3, comma 1. And this is X, this is Y. So what will happen or what will follow then? We have to coordinate, or to connect the points. How and which way? Get the ruler. There's no end of using freehand here. Get the ruler. You're using the graph. And also connect them clearly and perfectly. The first question talking about draw a triangle. Please don't mind. Just trying to indicate, showing. If you have a ruler, it's going to, using a ruler is going to, and also graphs going to be shown perfectly. So this is our first question has been answered. According to the question itself, it was all about draw the triangle ABC, show by just the first normal numeration to say draw the triangle ABC. Then, what will follow after this? The second question is going to say show by calculating the triangle ABC, the one that I've drawn. You have to show to say this is isosceles triangle, and name the two angles which are equal. Okay, great. Probably the angle that might be equal, we want to say the triangle has two sides which are equal. It is this side and this side. So what's going to happen? We're going to get the coordinate of AB and BC. So that means AB, that means to say AB should be equal to BC. Then that means to say it's isosceles. Can we show by calculating? Hence, we're going to use the formula of distance. Shall we? Let's go. So the AB and BC supposed to say, well, it's supposed to show to say these angles, they are equal. Well, let me say these sides are equal by distance, and also they're contributing to the fact that the triangle is isosceles. So what's going to happen here? We have to show to say this distance that equal without failing. This distance that equal without failing. So what's going to happen? What are you going to do to show to say they are equal? Indeed. We're going to use the formula for distance, which symbolizes to say we're looking for distance and the distance should be equal. Okay, we'll say AB is equal to, label it very much carefully, say this is x-axis or this is xy, this is y1. This is x1, this is y1. What is our x2? Our x2 is this one. So we say 7 minus. What is the x1? So if you multiply negative times negative, that is positive. Square there. What is our y2? That is 4 minus what is our y1? 2 squared. I should be equal to this side also. Open up. What is our x2? That is negative 3 minus what is our x1? 7 squared plus. What is our y2? Negative 1. What is our y1? Plus 4 squared. And they're supposed to be equal. AB is equal to 7 plus 4. That is 11 squared plus 4 minus 2, 2. That to 3 minus 7, that is negative 10 squared. So if I try to take you back a little bit, I'm going to have, this is supposed to be a negative, according to the formula. So that is negative 1 minus negative 4, that is negative 5 squared. Then we say AB is equal to 11 squared, that is 121 plus 4 should be equal to what is negative 2, what is negative 10 to the power 2, that is 100. Negative 5 to the power 2, that is 25. Using the law to say, if the negative base being powered by even number, the answer is supposed to be positive. So we say AB is equal to, this is given as 125, I should be equal to 125, and what will be our distance, which is the square root of 125. You should try to calculate it very much properly. Get a calculator. You say, try to switch it on. What is the root of 125? And your answer is 11.18. If you try to round off into one decimal place, that will be 11.2. So I'm going to have 11.2, which is equal to BC as in 11.2 also. Centimeters. So this was to say, distance, they're equal. This distance, they're equal. Or contributing to the fact that you say therefore, triangle ABC is isosceles.